Okay. Um, so since we're talking about interfaces, I wanted to kind of talk about something that's kind of a big topic in computer science that we've only kind of touched on just a little bit. Um, so when you're dealing with different programs, you're going to have data that you need to collect and store. And we've talked about arrays, and we've also talked about array list. Okay, so hopefully you have a pretty good handle on what an array list is. Um, but there's a lot more ways than just that to hold on to data, more data structures than just that one. So let's start with an interface called collections. That's kind of the big umbrella interface that all of these other ones are under. Okay, and if we were to look at collections, if we were to look at the actual code there, the methods that you would see, there would be a bunch of them, but the main ones you would recognize is add and remove and size. There's also contains and equals. Um, so if you have a collection, anything that you see on this page, you should be able to add to it, remove something from it. You should be able to check how big it is, see whether it contains a certain element, and see if two collections are equal. Okay? Um, so, everything else that we do is just going to be an extension of that. Okay? So, let's start with the one that we know. We know list. Okay? Now, list is a sub-interface of collections. So it actually extends collections. Okay? It doesn't implement collections. It extends the functionality of this interface. Okay, so we would extend collections, and you have something called list. Now, all it is it's an indexed collection, meaning that every element has a number attached. So if I say, hey, get the thing that lives at index 7, it can do that. Get the thing that lives at index 2, it can do that. So now we have get and set. So if I say, hey, get the thing that lives at 2, and we can set the thing that lives at 2 to something else. Okay, it's just a collection of stuff that happens to be indexed. All right. Now, again, this is just an interface. What implements that interface? One is array list. So we can make an array list that implements list. Okay. There's also sets. Now, sets are collections that can only contain one of each object, so no duplicates. So if you try to add something to a set, it kind of checks and goes, do we already have that? If it doesn't, it adds it to the list. If it does, it goes, no, can't add that to the list. Okay. A basic set is a hash set. Okay. There's also a sorted set interface that extends the set even further. And a tree set is a basic sorted set. But keep in mind, all of these can add, remove, check the size, see if something is in the list, see if it equals it, even if it does it in a slightly different way. Like, for example, adding. When you add something to a list, it just adds it. When you add something to a set, it has to check, is that already in there? Okay, so it's the same action, but it does it in a couple different ways. The last extension of collections that I want to talk about is a queue. Now, if you live in anywhere that speaks British English, you know that a queue is like a line where you're like waiting for something. Now, a queue has methods that interact with the head of the queue, okay, like the front of the line. Like, who's going to get served? Well, it's going to be the front of that line, and you have these new operations, pull and peek. One of them looks at the front of the line, and one of them takes what's in the front of the line. Okay, pull takes from the front of the line, peek looks at the front of the line, the front of the queue. And a linked list is an indexed collection, but it also has these operations that a queue has. Okay, you can pull and peek. And then you've got a priority queue, which sorts your queue based on some sort of comparator that you have set up. Like, hey, I want you to sort it by this first, and then this, and then this, and then this. So sort it by all these things, and then rank them based on that. And whatever's at the head, that's what I'm going to deal with next. So these are all different data structures, but the cool thing, again, is if you can understand what collections do, when we're looking at queues, you may not know exactly how a queue works. You may have to look at the documentation, but even before you do that, you know that you can add, you know that you can remove, check the size. You don't have to completely reinvent the wheel because this is implementing this. Okay? So data structures is really something you want to dig into later. It's also something where some of these, it may not seem to make much of a difference, but it makes a huge difference as far as performance goes. How long does it take your program to run? Which right now, that's not a big deal. You're just like crossing your fingers that it does run. In the real world, you want to make sure it runs quickly, efficiently, both for time reasons and for battery life and all of that. So I hope this was a good sneak peek into the world of data structures.